Right, let's look at this problem. For a sequence, if Sn, that is sum of n terms, is 3, 2n minus 1. We have not been given whether it is a AP or whether it is a GP or whether it is a HP. So find the nth term and show that it is a GP. Also find R and the value of nth term. Now what is the logic that is going to get involved here? We have to find out the nth term. The reason why we have to find out the nth term is because if we happen to divide the nth term by its preceding term, we will get a common ratio, and if this happens to be a constant, then this is a GP. This is the thing that we have to prove. Now how do we get the Tnth term? Tnth term for any kind of series will always be the sum of nth term minus the sum of preceding term. We have also got to find out Tn minus 1. This will be Sn minus 1 minus Sn minus 2. So let's find out the Tnth term first. So if we have to find out the Tnth term, this will be, we substitute this as 2 to the power of n minus 1, and for this n minus 1, we will substitute 3 to n minus 1 minus 1. So this gives you 3 into 2n minus 3 minus 3 into 2n minus 1, and this will be plus 3. Both of them get cancelled. You again take out 3 as common, and in fact you can take out 2n minus 1 as common as well. So you will be left here with 2n. n minus 1 into 2, this will give you 2n minus 1. So this gives you 3 into 2n minus 1. So your Tnth term is 3 into 2n minus 1. So your Tn minus 1th term, by just looking at this, you can calculate this will be 2n minus 1 minus 1. So that's going to give you n, 3 into 2 n minus 1 minus 1, that will be 3 into 2 n minus 2, that's going to be 3 into 2 n upon 2. So your Tn minus 1 is 3 into 2 n upon 2. Now let's divide this. So this will be Tn by Tn minus 1, that's going to be 3 into 2n minus 1 upon 3 into 2 upon 2. So let's quickly look into this. This will be 3 Tn minus 1, this is Tn minus 2, I'm sorry. Tn is 3, 2n minus 2. So this can be represented as 3 2n minus 2, and here we have 3 2n minus 1. This 3 and this 3 gets cancelled. We have here 2n minus 1 minus n minus 2. So this will give you 2n minus 1 minus n plus 2. So n and n are going to get cancelled. 2 minus 1 is going to give you 1. So therefore Tn by Tn minus 1 is equal to 2. Hence this is a GP. And what do we have as a common ratio? The common ratio here is going to be 2. So how do we calculate the Tnth term out here? The Tnth term, the nth term is equal to Arn minus 1. This will be the nth term. So this will be A, and this R is 2n minus 1. Tnth term will be calculated like this. Alright, now we'll move on to the second one. If S1, S2 and S3 are respectively the sum of n, 2n, 3n terms of a GP. So let's say Sn we have. So we have to prove here S1 into S3 minus S2 is equal to S2 minus S1. So let's suppose let A be the first term of the GP, and R be the common ratio. Let A be the first term of the GP and R be the common ratio. So what will we have as the sum of the S1 will be equal to sum of first n terms, which is equal to A Rn minus 1 upon R minus 1. So this is going to be your value of S1. S2 is going to be S2n. So this will be A R 2n minus 1 by R minus 1. And then we have S3n. S3n is going to be A R 3n minus 1 upon R minus 1. So now we have to actually get this arranged and play around this. So S1, S2 and S3 are respectively the sum of n, 2n and 3n terms of a GP, then we have to prove this one. So let's go by this. S1 into S3 minus S2 is going to give us what? S1 is basically, let's keep it S1. Let's first see what is S3 minus S2. Now S3 is basically A R 3n minus 1 by R minus 1 minus A R to the power of 2n minus 1 by R minus 1. So this is going to look like something this, R minus 1, then we will have here A R 3n minus A R 2n plus A, this minus A and this plus A are going to get cancelled. We will have here S1 to A, which we can take out as common. We have here R3n and we have here R2n. So we can take out R2n as common and we will have here Rn minus 1 upon R minus 1. So this is S1 into AR2n Rn minus 1 upon Rn minus 1. So this is S1, S3 minus S2. Now look at what the RHS term is. The RHS term is basically S2 minus S1 square. Now S2 minus S1, if we have to square this term, let's look at this. So first we have not modified this S1, we have kept it as S1 only. Now S2 minus S1, we can see it categorically out here, A R 2n minus 1 by R minus 1, and this is S1, which is A R n minus 1 by R minus 1. So if we take out the A R minus 1 part as common, we will be left with R 2n minus 1 minus Rn, or this is plus 1. This gets cancelled. Again within these two, we can take out A R n as common. We will be left with R minus 1, and we have here R2n minus n. So this will be Rn minus 1. So this will be Rn minus 1, AR2n. Now if you very closely look into this, ARn by Rn minus 1, Rn minus 1 by R minus 1. So we have a R2n. R2n can be taken Rn as common. This will leave you with Rn minus Rn. We have already taken it out as common. So this has to be squared. So if this has to be squared, we will first out. So this will be S2 minus S1 squared. This will give you A R2n A square R minus 1 square to Rn minus 1 square. So if we look into this, A R2n Rn minus 1 R minus 1, if you multiply this by S1, this is going to be, S1 is, we have here A R n minus 1 by R minus 1 into A R 2n R n minus 1 R minus 1. If we get this multiplied, we will have R minus 1 square, A into A square, R into 2n, and then we have Rn minus 1 square. So if we compare these two terms, the one that is here, A square R2n Rn minus 1 square R minus 1 square, A square R2n Rn minus 1 square upon R minus 1 square, both are equal. Hence we can conveniently say that S1 into S3 minus S2 is equal to S2 minus S1, and that's the whole square. Alright, we will have another problem from IIT 1982, and this is basically related to the GP thing. The third term of a GP is 4. So basically for a GP, the third term has been given as 4. The product of the first 5 terms is 4 cube or 4 to the power of 5 or 4 to the power of 4 or none of these. So this was again an old problem from IIT, but let's look into this. So if we have the first term as A, so let first term be A and common ratio B, R. So we have here the product of first 5 terms. First 5 terms will be A into AR into AR square into AR cube into AR 1, 2, 3, 4. This is equal to the third term of a GP is 4. So how much will this be? 1, 2, 3. This third term is 4. We know that AR square is 4. So this is going to be A, and A. 1, 2, 3, 4, 5. A to the power of 5. And this will be R into R square into R cube. 4 plus 3, 7, 8, 9, 1, 10. So this is R 10. So we can write this as AR square to the power of 5. And we know AR square has a value of 4, since it has been given to us that the fourth term of the GP is 4. So this will be 4 to the power of 5, and hence the correct option here is going to be B, which is 4 to the power of 5.